Okay, hi everybody. Why is my audio threshold so high? Oh, there it's down again. Okay, so yesterday we did this work on the terrain rendering. Got the basic terrain rendering going, did not quite get the continuous LOD going. Tried to debug it for a while, couldn't figure it out. So I stopped, and then offline I went back to it and figured out what I was doing wrong. And we're going to go through what I changed to make it work. So if I turn on the debugging, now you can see that everything is moving relatively continuously. The colors are supposed to change when it switches between, like the color of a block changes when it switches which level of detail it's coming from. So those pops of the color changing are correct. And if I turn off the debugging information, you can see there are no black cracks anywhere anymore. Everything's continuous. That's a weird artifact. I wonder what that is. Oh, that's, yeah, it's something in the lighting that's due to something else not to worry about. That's just a baked artifact in the lighting. Because actually I changed something, and I think the lighting maybe doesn't fit the terrain anymore. Or maybe it does, actually. Looking at that slope right there, it does. So, yeah, anyway. So we'll go through what changed here. This is, of course, set to a very low level of geometry, not what it's really supposed to be. So if I move around, you can see, let's find a place that's going to change in the distance. Okay, so like you can see this vertex crawling along, and so if we move towards that, right, you can see this terrain sort of lifting. Everything will look like it's moving up and down, even though it's all actually moving, the vertices are moving sideways, but that's just because we keep the texture projected to the right spot, and so the visual movement of the texture is just vertical up and down. Right, so here you can just see everything is just shifting around. And like I said, that's just because this is set to such a low level of detail. Like once we push that out, it's way less noticeable. So let's talk about what went wrong here. Let me check the chat real quick. Okay, so we will talk about what went wrong. So I think 3 things were going wrong in the code that we were looking at. So we're going to do magic here. I guess we'll go to face cam. And magic. Yeah, the whole thing about rendering quads is it's just turning them into triangles under the hood. It just uses 2 triangles. And you might want to actually switch to using triangles so you control how it splits the quads into triangles, so it's always consistent, because that could cause a popping right now. Is maybe when it switches levels of detail, it switches which way to split the quad into triangles. I don't think that ever currently happens because it's always deterministic based on the order of the vertices probably, but it's probably a change worth making just to be guaranteed, is to just actually force the quads to triangles, and that way it's the same on all drivers and stuff. So this is a scheme we kind of got to, and it's the scheme that we're using here, which is that these vertices here we're looking at the edge of a ring of quads. You know, they're in a grid, the grid keeps going out. And sorry, gonna do this. And gotta do this. Okay. Oh, except that hides chat. Right. I remember this. So basically, in each quad, in each, not quad, in each, if you split the map up into 2x2 things, each of well, if you split it into 4 quads is basically the idea. If you look at 4 quads along the edge, I should have drawn this bigger, I'm sorry, but this was just what I was doing when I was solving it. But if you look at these 9 points, which form 4 quads, you can see that this point, and this point, these 2 points collapse to here, this point collapses to here, this point collapses to here, this point collapses to here, and you end up with this shape we were seeing as you're collapsing, like that, as those all collapse down. So we basically had figured this out the last time, but didn't quite make it work. And there's a couple reasons for that. Okay, the first is, we had this idea that if you're near the north edge, you have to, okay, first of all, you have to always match up to the next level. So the next level looks like this. And so the x's, you can't have a vertex there because it won't match the neighbor. So I just figured that out towards the end, that these x's just always stay collapsed to their neighbor. So you don't even actually need them in the mesh, but I still have them in the mesh because it keeps everything more consistently organized. And they just stay collapsed. But so then we had this idea that along the north edge, as you move up, or as you move down, let's say as you're moving down, you're walking backwards looking up. So these collapse, and we'll eventually turn into one of these. And the way that works is 3 of them all move to this vertex. Oh, and I accidentally erased one of the lines. And it's a little inconsistent what happens because this is the north edge. The south edge would be more like the west edge because that's towards 0, 0. Like the origin is down here. And they just all always move down, left, or left. So at the different edges, different sorts of things happen. So because the x's have been removed, they're always collapsed out. It always matches up to the neighbor, and I just figured that out. And then I was working on this idea that along this edge, as you move, I had started to say, as you move away from the north edge, looking that way, these edges have to start collapsing, and then the one on the very edge has to collapse to match the way this thing will be once you move by 2 rows, so that this thing can now actually become part of the lower level of detail. So we kind of figured that out. So the 3 problems are, the first problem is that in the code, I was doing this draw ring code, and if we look at the else of this if, I was trying to do this logic inside the ring for how to collapse things, but I'm iterating over quads here. And so for each quad, I'm trying to do the logic for what should collapse. And that's wrong. And I kind of knew that, but just didn't quite put it together. But the reason that's wrong is because we're trying to make one big continuous mesh. Everything should be continuous. Everything should be connected. That's how we avoid gaps. That's how we make it successful continuous LD. And that means this vertex here so this pair of vertices, and there's an orange one, right? So it's this area, is part of this quad, but it's also part of this quad, and this one is also part of this quad, and this quad. So if we draw this quad and we move this vertex over to here, we need to move this vertex. We need to if we draw this quad and we make the blue vertex move to green, right? Then we need to make if it collapses to green, then we need to make, when we draw this quad, we need to make this vertex collapse to green. And when we draw this quad, we need to make this vertex. And when we draw this quad, we need to make this vertex. And all of these all need to collapse over to the same point. And I'm drawing them as different points just because they're disconnected quads, just to make that a little clearer. But all of those are the same vertex, and they all need to move to the same place. And so when you try to do the logic per quad, it doesn't really work very well. And I forgot to switch scenes. I apologize. So we'll do that again with the scene. How come nobody complained? You guys gotta complain at me for not switching scenes, not that I would have noticed. Or unless you could somehow follow them, the tiny one. So all I was saying is, this quad right here, all these vertices collapse. That's this quad here, so this vertex collapses. But the adjacent quads to this vertex all share that vertex, and they all need to collapse to the same point. And so in the code, like I said, I was iterating over the quads and trying to decide what all four of the vertices do in that quad. And the problem is, like, the logic, the logic tries to decide, well, which quad am I in, and then like which vertex am I manipulating, and try to get it right, and that was buggy. That was never going to work. So that was mistake number one, and we'll look at the code in a moment. Mistake number two, there's just some subtlety to the corners. So basically, when you move north or south, there's a light blue color. I don't know if you can tell the difference between light blue and the dark blue. I'll circle the light blues. These are the ones that have to move when you go north-south. These are the ones that have to move when you go east-west. And then we had a corner vertex or corner quad that we would update the corner to the max of either the north-south effect or the east-west effect. And that's now actually turns out, when I thought it through, it's actually 3 different vertices that have to do that, which I just hadn't thought of at all at the time that I was doing this originally. So that's the second bug. Maybe there's 4 bugs. So for the people who have any clue about what we were doing yesterday, does this make sense so far? Yeah, I've tried to do that stuff, and with drawing with a mouse, I'm so much worse at drawing with a mouse than with the thing. And also, I don't think the diagram would actually be any better. I know from experience when I was doing this stuff with Milton or whatever that I would just be overdrawing, and it's just as messy as this does. But I should have drawn this bigger. I definitely should have drawn it bigger. That's like I said, I only drew this originally for my own purposes and figuring out this color scheme thing. Okay. But I'm going to erase this, so... no, this is not voxelless terrain rendering. Voxel rendering is on Voxel Fridays. So, here's the second mistake, or third mistake, is that I said that I think these are just all the same vertex buffer always. Because you're kind of forced. Once you put down the outermost one, you have to match it with the next inner one. And then that one has the hole that you have to match. And that was incorrect. So let's look at why. Let's say that our innermost ring is 4 by 4, just to keep it really simple. We don't care about the magic that happens for the fix-up. We just know that there is magic that happens for the fix-up. At 4 by 4, it would look terrible anyway. So we're just saying, you know, here's the next outer ring. And maybe this is too deep. One more. So, what can we say? So the current idea is, as you move the camera around, you move the rings so that they all stay centered on the camera, but they have to stay snapped to their own alignment. So, if the camera is right here, this is what we get. And then as we move the camera over to the right, say we get to here, we could move this whole thing over by one row of quads, right? We could erase this one and say, okay, now we've moved over by one. But the problem is, we're not allowed to shift the next one by half of a quad. We want it all to be stable. So there's no way to fill in the stuff here with these quads. This is a full-size quad. I'm sorry for the terrible non-squareness of my quads. This is a full-size quad, and that's a half-sized quad because I made that one narrow. So we actually have to move over 2 of the innermost thing. Before we can move the outer one. So we actually have to snap the innermost one by 2. And we were doing that. That was true. We had that. So we just don't move the... that one doesn't subdivide. So we just don't move the inner ring until this whole thing has moved by 1. And then the obvious thing here is that now we move this whole thing over by 1, because we moved this one by 2, so we can move this one by 1. And now it's double wide at both sides again. So that's, like, conceptually what I thought was going on. But it doesn't quite work. And the reason it doesn't quite work is because there's another bigger level of detail outside of that. And we just said, we move this over by 2, so we move this one over by 1. But now the next one, if we now pretend that call this ring 0, this is ring 1, this is ring 2. So ring 0, we had to move it by 2 before we could move ring 1 by 1. Right? Because if we moved ring 0 by 1, there was nothing to fill in the data. So we said, okay, we'll move ring 0 by 2. We won't move the ring 0 except by multiples of 2. So we moved it by 2, and we said, okay, now we can move ring 1 over by 1, world space the same distance. But now ring 1 is moving over by 1. How do we fill in? Before we moved it, it went to here, actually. Right, and so the outer ring looked like that. Right, this is what it was like before we moved it. So now we've moved it, and we've created this gap here, and it's narrower than this big thing. So there's no way to fill this data in. So this whole strategy can't work literally the way this works. Yeah, VFig is exactly repeating back a correct understanding of it. That doesn't mean this doesn't work. In fact, I had it working. I just didn't understand what it was doing. So I didn't realize that it's not always the same vertex buffer. You actually need 4 variations. So what you do, say this is the second ring. So there's a much finer ring in here. Push this out one. So there's a, the quads are this size inside this ring. So when we move it over by 2, yeah, I'll go ahead and draw it. Like, this works. Right, so here's our situation. We can't move it over by 1, but we can move it over by 2. So we move it over by 2. And we fill this in with the next level of detail. And that's it. We don't move the outer one because it's only moved by 1. It would only be moving by 1. So we create a variant representation here that's off center by a little bit. It's the whole, basically the hole in the center of each ring needs to be able to move by 0 or 1 in each axis. So there needs to be 4 variations for each thing. Either the hole is here, the hole is here, the hole is here, or the hole is here. And if you do that, then you can always do this thing where the lowest level one moves by 2, and the parent either moves by 2 or it switches to the next one over, to the next hole over, so that the hole still matches. And then the next time that one you move the innermost one, you definitely now like, let's say that over again. The first time you move the innermost one, you move the hole in the parent. Then the next time you move the innermost one, the parent can move over by 1. And that's true recursively up the whole thing. So that was kind of working in the code, but I just didn't understand what the actual behavior was there, so I didn't realize that it was going to need 4 variations. Now it's going to turn out in the long run that we actually get to use the same vertex buffer for every ring, and so we don't need 9 rings times 4 vertex buffers. Not that that would be expensive or anything, but we don't actually need 9 rings times 4 vertex buffers. We need 2 rings times 4 vertex. We're actually 1 ring with 4 variations, and then one thing to fill in the centermost one, which doesn't have a hole. Okay, so that was the 3rd error, and I can't remember what the 4th error was. But I'll think of it while we're looking at the code. Yeah, I mean, the thing is that I'm streaming not so much to communicate well to the audience as to motivate myself to program. So, yeah, there's limits to how much I'm willing to do. I got to move the mic. Sorry for this. I got to just kind of mute the mic or something. Mute button, a hotkey for muting. Okay, so the first things first, all the vertices have to behave the same. So here we're iterating over all the quads. We start drawing quads. We iterate over a ring, drawing the quads. And in the old code, we did all this logic. And in the new code, we just draw the 4 vertices by making a function call. And we pass in, like, okay, where's the boundary of the thing? We pass in the coordinates of the vertex and some so a little bit of debugging stuff and the collapses. But basically, this way we guarantee that when we see the same vertex in different quads, we'll always do the same thing to it. So here in this code, it's a lot complicated. And as I've said before, effectively all that this is doing for the most part is computing flags that the vertex shader could use. We do it in the code here, but that the vertex shader could use to do the computations. And those flags are going to just be static for the vertex buffer. So the complicated logic here will just all get baked into data. And so the details don't matter too much. But the details are just doing, when I had the illustration of the how all the vertices slid, and I had the three different colors of the vertices around the thing. This is logic to compute all of that. Here, ring 0, 1, 2 means something totally different. It's the ring of vertices at the edge. So ring 0 is, are you in the edgemost column? In ring 0x is really, are you in the left or rightmost column? And in ring 0y is, are you in the top or bottommost row of this quad ring? And then 1 is, are you 1 away from the edge, and 2 is, are you 2 away from the edge? And using that, you can figure out, and the parity, if you're on an odd or even, you can figure out which of the colors it needs to be. It's possible to arrange the vertex buffer for a ring so that you get the extra quads at the start end of it, so you just draw different ranges of quads. Yeah, probably. No, not with 4 combinations. You could do it with 2. Right, because you can draw the extra at the start or end. So you would shrink it down to 2 vertex buffers in the start and end. But I'm planning on using start and end cropping of quads as Frustum culling. So I'll just have 4 vertex buffers and not have to worry about that. Right. The Frustum culling idea, I mentioned this, but I didn't give any details, is you basically sort the quads in order around the ring. Basically into chunks, and then you Frustum test the chunks, and most of the time you'll get, like, or hopefully all the time, you'll get kind of a continuous range of them that needs to get drawn. That continuous range might cross over, like somewhere you have to pick a boundary. So, at, it goes from 0 around to 360 is the order. And so if you need to draw quads, if what's visible is this chunk of them from -90 to 90, then that crossed the boundary. So you have to draw the beginning and the end of the vertex buffer. But you can do it in 2 draw calls is basically the idea. Which is over-optimizing. The number of draw calls you could probably do is probably not a big deal if we only have 9 rings, but, whatever. So I'm not going to go through that in detail, but the upshot is this is just determining those 3 colors for which axis you need to collapse along according to that crazy logic we were looking at. And it's just recomputing it from scratch every frame, totally inefficient, because this will all get baked into a thing. What did I want to do? I want to actually make bigger rings so we can see what that actually looks like. So now, can I find somewhere that's moving? I saw, oh, right, of course you always see color popping. Okay, so if we turn that off, can we see movement? Yes. Well, okay, yeah. Like, that's pretty obvious because, first of all, I'm moving way too fast. But this is artifacts with the hacky lighting that, well, actually, it's not just the hacky lighting. It is actually that you've got a slope along the edge there. Right, this is like, right, that's too steep a slope is the problem, right? I've said that anywhere that you really want something vertical, I'll put a rock face that's an object in, because too steep a slope is going to have that artifact. Like, here's a better example of, well, it's still the very steep slope. Also, the transition is too sharp between the two, and that's another thing I'm going to do is I'm going to actually cause everything to be rounded. I've actually got the code for this in here. It basically, instead of sampling the height map, and effectively it's creating flat triangles across where the height field is, you can, or I do bicubic interpolation of the height field, which creates a smoother thing. When you're far away from it, there aren't enough triangles to actually show the bicubic, so I'm not sure it would affect this case, but I think it would. I think I think that's actually at a distance where that would come into play. And so that stuff would automatically be a little smoother and not so artifacty. But it's also, you're mainly seeing the lighting change, right? So first of all, if I move at a realistic speed, this is like a human running speed. Well, let's get down to the ground and get an eye level that's maybe human eye level. I don't exactly know. I still have to write that code. So we should see some things here change. Yeah, okay, I'm zooming in to see it. If I don't zoom in, you kind of can see that stuff is changing over time. But again, this is the super steep slope. That's not the case I actually care to make work. I guess the frame rate is capped at 60 FPS. Yeah, we looked into this the other day. It shouldn't be. I've turned off VSync. Did I do it before? Is it the same bug that I didn't do it before init? Oh yeah, we tried to fix it. I originally didn't do it before init. Now we do it before init. And my driver is set to not override it. So I don't know why it's not actually disabling VSync. Other apps, other programs that I run using the same thing, it is working and disabling VSync. So I'm not sure why it's doing that. But yeah, but you can see the frame rate in game. Like that thing was, you could see it was 16 milliseconds, which is 60 FPS. The frame time stabilizes down to 16.67 or whatever. But also, 100,000 quads isn't that many. Like, it's 200,000 triangles. And so, you know, I as we talked about, my 680 Ti, much older, I was pushing 40 million triangles in the voxel stuff well, that's a pretty huge geometry change. Oh, it's super steep again. Yeah. Although that may be a slope that I should work. So we'll have to see what happens when we stabilize the lighting and other stuff. I mean, actually, the lighting is all baked, so the lighting should be totally stable. It's just that it's getting stretched up over larger things. So it's more like we need to tweak the tech. Anyway, I don't know. Maybe this doesn't work. Maybe I need to maybe I will need to switch to quad chunks and some kind of knowing how much detail there is and doing something. But so I wanted to try this strategy, and maybe we learned that this strategy isn't good enough for super high quality. But I was saying we can push the level of detail out further because, like I was saying, I was doing 40 million triangles at 30 FPS on that old thing. So, you know, maybe this thing could actually easily push, you know, 16 times as many triangles. But not in this version because I'm running a debug build, so this is going to start being slow on the CPU. So who knows? Okay, so anyway, so the first bug I fixed was doing every vertex independently. The second bug was dealing with that hole at the center that needs to move around. And so now it just very carefully, unlike the old code, it says, here is the outer bounding box that we draw is is centered around OXOY and is from here to here. Like I could be explicitly computing an x0, xy, x0, x1, y0, y1 here, but I'm not, because then the thing you immediately do is, because this is making the vertex shader add that back in. So basically, if the vertex shader weren't adding this in, we could set this to 0, 0. We'd add OX, OY to everywhere here. This would be very explicitly OX minus O radius, OY minus radius, OX plus O radius, OY plus radius, and these wouldn't have the subtraction. And then you can see that we just save as the new inner ring whatever the old outer ring was, right? I just said the old outer ring was OX minus O radius, OY minus O radius, etc. So we just save it explicitly, and we use that as the new inner ring, whereas the old code was trying to do it logically, and it wasn't quite right. So because of that same offsetting the interior thing, I think. So the new code just explicitly stores what the previous ring's outer ring was, and uses that as its inner ring, guaranteeing that they match. And then, what was the third thing? The third thing was already being handled in terms of us doing this stuff, because I don't think I changed anything else here. So yeah, so there were three or four conceptual mistakes, but they were kind of right in the code. So anyway, that's all it had to actually change. Was I changed this broken logic to this correct logic, and then that whole thing about processing the vertices. But yeah, this all is meant to be on the GPU. I'm just doing all of this work, as I said. So the whole thing is that because I do this base, that thing we saw with base, these rings are centered around OX, OY, so their vertex coordinates are centered around 0, 0, and the vertex shader pushes them off to be OX, OY. So because these rings are centered around 0, 0 in terms of what they upload for vertices, they're actually all the same with 4 variations. So, and I did it this way so that they are all the same. And so that just means that we can cache all this data because it doesn't depend on where it is on the map. This draw ring call actually computes the same thing for 4 variants on every time it's called. So we can bake this stuff into vertex buffers, put the little bit of extra collapse logic into the vertex shader and make it all run on the GPU. That's certainly the intent. It's just that right now all of this code is running on the CPU while I was getting it working correctly, because it's a lot easier to debug it when it's being done on the CPU. So that's it. That's the fixing the bugs that we were looking at yesterday. Oh, this is still with the 1.8 million. So, but the point here is that 1.8 million still isn't that many triangles. So maybe you could have that many, and maybe that'll be enough for this to be fine. And different hardware can have that set to do. That can be a setting, geometry detail. Let's put it down to 128 and see if the machine is fast enough. And it's a debug build, so it's being done on the CPU in a debug build. So it's not like, yeah, it's still too slow. 64 is actually right at the limit. But anyway, so yeah, that's the entire stream. I did say it was going to be a short stream, so I'll take questions. Let me go ahead and re-implement the or re-enable the bicubic stuff. So we do that, and then we scale the map. Here by 8, and we resample the map here. And then we have to rescale the height. Yeah, VC6 has inline assembly. I did not quite get the scaling factors right. What did I forget? I'm multiplying the height by 4. I did the scale by 8. But that's only a difference of 2. Yeah, I'm missing something. What? 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 Uh... Uh... What? 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 Okay, well, let's just ignore that, I guess. Why is this all flat? What? I feel like I broke this map load here. I feel like this just is flat. It is. Did I disabled that. Jeff's the plans to support wrong mouse. Caves, not just a simple height map. I probably won't do caves, but I will do underground, like through doorway or through foundation, you know, under things. But it is a height field, and the core thing that we have running right now is a height field. So it'll just have to cull little holes in it and fill stuff. Put enough geometry in to hide the hole, and if you move far enough away, the geometry becomes too coarse and there won't be a hole. But that's so I want to only put it inside a building so that to be far enough away that it stops drawing the hole. You can't see the hole anyway because it's inside the building. Like, if you have a problem with a thing being called Visual Studio, talk to Microsoft in the 1990s. That was their name. It's not. I don't know what that has to do with this stream. Your XY sample is being scaled. Yeah, that's intentional. I have to do that so that the bicubic has space to work in. It shouldn't make the thing absolutely flat. Why is the thing absolutely flat? What did I change? Okay, let's put it back. Now I still have the scaling, the map scaling, I think. Oh, I don't. Okay. So first we scale the map. And now it stretches it out over a much larger space. And then we go into the cubic. This was working, so I don't know how the cubic would break. Okay, now it's still bumpy, and we haven't introduced the crazy thing. So I don't know what I just undid, but I undid something that broke it, and I don't know what it was. So now we amplify the height again. Or no, actually we do this resampling to bring the map, to make the map smaller again. Yeah, okay. We're under the ground, so it doesn't, seeing the artifacts isn't important. Okay, so now, although it's not obvious, everything is now this sort of nice and smooth cubic Bezier everywhere. There aren't any sharp corners now. There can still be the steep sloped areas. Right, so here's the steep sloped areas, and we can see what those look like as we move further and closer to them. And because if we move farther enough away, they're not actually even doing the like the Bezier only shows up on the first 2 levels. I think by the time you hit the 3rd level, no, what did I scale by? 1/0.8 or 1/8? Map scale 1/8. Okay, so yeah, the first. So this steps by 1, this steps by 2, this steps by 4. So right here, this is the last level that the cubic affects, and out here, the cubic actually doesn't do anything. But it does seem more stable, actually. The lighting doesn't match anymore because of that hack, I think. Actually, it looks like it matches, kind of matches. Maybe not. Yeah, no, okay. It just happened to be coincidentally matching. I saw a little movement. Yeah, right there. See, Control Z. Why is Control Z? Oh, because it lost focus. Yeah, you can see this. That sharp-edged artifact there. Again, I'm moving way too fast. And that is still too steep a slope, I think, is still the upshot of that. Any slope that steep is going to get covered up by an object so that to hide the artifacts. So yeah, I don't know what the bug was that was. Anyway, all right. So, any more questions? Please ask. And I'm just going back. Can I git diff? No, this isn't in git. Can I diff with my CMIR control system? Not easily. Oh, that was a suggestion for fixing the bug. So yeah, I mean, I just undid and fixed it. What used to be real jaggy on the top edge of the steep slope is not smooth. Yes, that's hopefully what's going on. Although it's hard to know where the steep slope, that this is the same steep slope or not. I decimated it. Like it's only got a quarter as many samples, and then it's sort of filling in the remaining samples with the bicubic. So it is forced to file away the edges. The plan is, let me talk about that. The plan is that you have this very coarse map. It's every 8 meters. We're doing a 32K by 32K meter world. So maybe it's 8K by 8,000 by 8,000 samples, or sorry, maybe it's 4 meter by 4 meter spacing, or maybe it's 8 meter by 8 meter spacing. This is 8 meter by 8 meter spacing. And then you bicubic across that. And that gives you these really soft edges. I mean, these aren't, you can see these look like they're cubic curve rounded right now. They're still steep, but they have the rounding on either side. The idea is that I want like 1 meter resolution, but a 1 meter resolution with 32-bit floats at 32K by 32K is too big. So we go to 4K by 4K or 8K by 8K samples with 24 or 32-bit precision, or maybe only 16-bit precision actually, and do that as a coarse thing. Then we'll have a fine overlay, and the fine overlay will be virtualized. So you only get the fine height overlay in particular places that need it. So boring places that you haven't manually edited to create interesting stuff, it might as well just pick up you're out in a field and the field is a little bumpy. Like probably this cubic is just fine. And so we'll put the 1 meter by 1 meter height field resolution data where it's needed. I was originally thinking that I would sample, I would allow the rings to go down smaller than 1 meter by 1 meter. Maybe they'd go down to 0.25, and so a quarter of a meter. We could have the let's turn that. Let's turn that off. Let's turn the black or the holes off. and just have color. I was thinking that maybe we would have a finer tessellation down to 0.25, 0.25, and do the cubic where you have the 1 by 1 meter page virtualized data pages that have some more fine detail, that those themselves could get cubic smooth, but they'll only be cubic smooth if you actually tessellate the geometry down more than 1 meter by 1 meter, and it's not clear to me that we actually need to. Let's see, I'm trying to think. I got to put in the code to put you a meter above the terrain, or 163 centimeters above the terrain, so that I can see what it should really look like and get the texture size right before I make that decision. But it's kind of looking to me like maybe we don't need that. And if we go back to this data that I showed very early on, you can see here's what we're currently rendering. Coarse data sampled by cubic. Oh, I can show you that too while we're here. So if it's this is currently 8K by 8K, but if it were 4K by 4K by 2 bytes, it would only take up 32 megs. And then you have this page table. Oh, this was actually an idea for an intermediate level. Who knows whether I do it. I don't know that I want to do vertex normals this way. So the current plan that I have is there are tricks that you can do to do the bicubic Catmull ROM sampling in 2D using only 4 texture samples by positioning the bilinear taps in the right places. But I don't do that, and I don't plan to do it. So I explicitly fetch all 16 and compute the weights. And the reason for that is because I also want to compute the partial derivatives, which you can do directly from, I have the setup for it here, which you can do directly from the bicubic, because the Catmull ROM explicitly knows, one way you could think of it is that the Catmull ROM, you're explicitly setting what the slopes are on either side, but you can also just take a derivative of the thing. And that way I can compute the partial derivatives at the vertices and actually get the normals, because now it's but because I made it bicubic, I can now actually get the normals just from the same bicubic computation. And then when you substitute in the finer details, there will be some kind of finer normals. And then, of course, you can normal map it with the actual textures. I have vague memory of you doing a talk on megatextures. Like it was just one talk on the subject, I could find it. Is that something you've explored in later years? No. No, we like I said with this, I have a lot of things where things get a little bit virtualized. I showed off the ship in the space project, the idea that for capital ships I might want to have really big textures, and so I made a tile mapping scheme that fetches the textiles for big surfaces out of indirected through a tile map, which is also very similar to virtual texture mapping. So I've done things like it, but I haven't done that explicitly, the megatexture style thing. Wonder if it's possible to describe the fragments of the holes caves using other primitives in our depth buffer stencil. Maybe that would be too expensive. The plan is that either the vertex shader collapses it to be a degenerate triangle, or the pixel shader does a discard. But the pixel shader doing a discard could still be done out further, but I kind of just don't want to deal with the complexity of the pixel shader now has to be able to have multiple regions that it can check, like multiple holes might be visible in the same region, and so the pixel shader starts having to check a lot of space potentially. I guess maybe it could just be in a texture. That's actually less efficient. You really don't want textures. Do you have a delineation between what should and should not be handled on the GPU? Is it as much as possible on the GPU and the rest on CPU? Yeah, basically. So I've mentioned this before, is that usually everything is GPU bound. There are lots of discussions of shipped games that are not GPU bound. You want it all to be GPU bound. If you're not GPU bound, you just bump the resolution up and then you're GPU bound. But you want to try to get it so your GPU is running at 60 frames per second. Your GPU is using 60 milliseconds. And so if you are only doing 4 milliseconds of work on the CPU, then you have all this free time on the CPU, and maybe you want to offload some things from the GPU to the CPU, or in another sense, don't offload everything from the CPU to the CPU to the GPU if you don't need to. Go ahead and do some work on the CPU if you have free CPU time. I expect in any indie game I might make, the CPU will have free time, and so it goes that way. However, anything where you're pushing lots of stuff, like lots of triangles, lots of pixels, just has to live on the GPU. But like I do Frustum culling. I would do Frustum culling on the CPU. I don't believe that I will need to do that kind of GPU compute, scene graph processing kind of stuff. This will eventually be moved to a vertex shader. Yes, Frustum culling depends on the camera. I'm not sure what you can still Frustum cull on either the CPU or the GPU. So I'm not sure what you think the gap there is. But like, so for example, talking about the GPU compute stuff, for example, if you want to do crazy reverb processing for your audio, you could offload that to the GPU, and the GPU could probably blast through it a lot more quickly than the CPU could. Maybe not because it's serially dependent, but the problem is, like, now you have this round trip time of uploading it from the GPU back to the CPU, so it's latent, and you're kind of wasting work because anything you do on the GPU that is not directly contributing to graphics is stealing GPU cycles from graphics. So that's my general way of thinking about it is the closer you are to pixels and triangles, the more you want to be doing it on the GPU. And the further you are from pixels and triangles, the less important it is to put it on the GPU, unless it's just not possible to do it on the CPU. For every frame, you need to push the new triangles to the GPU, because I assume Frustum culling changes the... Okay, so the triangles are stored... You describe the triangles in... Let me see how to put this. Suppose one of the things you're drawing is a building, like a house. And actually you have multiple copies of the same house in different places on the map. So you upload to the GPU a description of the house in its own relative coordinate system. You put the origin at the corner of the house or the center of the house. Then you put that in what's called a vertex buffer, and you upload it to the GPU, and it lives in VRAM, and it just lives on the GPU. Then on the CPU, every frame you say, is this house visible? The house is now positioned somewhere in the world, and you say, is this house visible in the Frustum? And if it is visible, you issue a draw call and say, draw that house. But you don't have to specify all the triangles for it, or the vertices. You just say, draw that house at this position. That can get offloaded to the GPU, and some people do try to offload that work to the GPU if they have a lot of different houses to draw, and people and characters and bushes and all that stuff, and trees and all that stuff. It can be too much work to even draw every object as a function call on the CPU. Here, right now, I'm drawing every vertex as a function call on the CPU, and that's super inefficient, but that's not what's going to ship. Do you ever use inline ASM for graphics work? Just curious. Not anymore. Well, I don't, because I'm mostly... Well, yeah, mostly this stuff all lives on the GPU now, so it just doesn't matter. And then SIMD lets you get more performance boost than assembly usually does. So making things run using SIMD, which there are SIMD macros so that you can do it at the C level, not at the assembly level, usually gets you, if it's work that can be SIMDified, usually gets you the performance you want. The thing is that, like, now that we have out of order processors, it's a lot harder to get assembly to go faster. It's not impossible. RAD, certainly the Kraken decoder is all assembly on most of the platforms because they could micro tweak that stuff and it was worth it. But there are a lot of cases where it's just not worth it. So Dev343 did that explanation that you're saying what objects to draw, not what triangles to draw from the CPU. Did that make sense? Okay. All right, I haven't seen any other questions, so I think we'll wrap. If I missed a question, re-ask it now before I wrap, but I think we're wrapping. Yeah, when I announced the stream, I said it was a short stream. And I think it's in the title too. I just wanted to go over this bug fix from yesterday. So that's it. Thanks for checking in. Thanks for putting up with all my whatevers. Intel ISPC, I know about, but I've never actually used it. Do you have an async API you like for I/O? No, I usually just have a background thread responsible for reading stuff and don't try to actually do proper async I/O. Like, the thing is, like, I'm not shipping AAA games. Most of the work that I do is very indie and involves small numbers of things, and so I just don't ever have to deal with a lot of the performance stuff anymore. It's only when I do graphic stuff that I really do performance, because there's not much point in doing graphic stuff unless you're at the performance edges. So yeah, I've certainly never made an internal API for it. Like, there obviously are per platform APIs for it, but I don't know. I've never tried to use those either. Like I said, I just put it on a thread and use normal I/O. All right, that's it. Thanks for showing up. See you. Bye-bye.